Okay, so what you wanted to know is you don't understand covalent bonding and ionic. Okay.
Yes, and those.
So these are the two you don't understand. Okay. So
And is it
the first,
that
yeah.
diagram as well? Could we also go through where it's like 3S and then you have to like the squares?
Yes, the Aufbau diagram.
Oh, yes. Could we go through that as well?
Yeah. Okay. All right. So first, when we think about bonding, it's not, a lot of people think of it as an abstract concept, or like if two things are bonded, you might think of like a rope tying something together, it's bonded. But when we think about bonding, what we actually need to think about is electrons. Because a bond is actually just two paired electrons. Okay, so when you think of a bond in chemistry, you need to think of it as being two electrons. Okay. So if you think of a double bond, that's two electrons together. And so if you see something like this, right, with oxygen and a double bond there, what we have is actually just 4 electrons. And so this area here is electron rich. Okay, there's just lots of electrons. So we think of this as being electron pairs. So that's really what a bond is. Now, let's look at specifically a covalent bond first. So a covalent bond, if we just want to, the sort of standard definition that's pretty simple to remember, it's two nonmetals that are bonded together. Okay, two nonmetals bonded together. So a simple one would be the one I've just drawn. Oxygen, your O2 molecule, is a covalent bond. Okay, so O2 is a covalent bond. And something like CH4, which is carbon and hydrogen, that is a covalent bond. Okay, carbon can have 4. So these are covalent bonds. That's covalent bonding. So two nonmetals. Okay, so when in doubt, if you see that it's two nonmetals, just say that it's a covalent bond. Okay.
Oh, so two non-metals compound is a covalent bond.
Yes, usually. Yeah. So I'm
Wait,
going to
so
say,
is there
I'm
a
going to say,
specific-
so to avoid confusion, yes.
Okay.
Okay. Now, we have what's next would be an ionic bond, right? And we usually look at this as being, particularly when you're in grade 9, a non-metal and a metal. Okay, so when we look at our periodic table, try and just remember that this is your metals in purple. Now, in your table that they give you, if they do give you one, that won't be in purple, but these are your metals here in purple, and then these are your transition metals here in light blue. So your metals are generally on this side of the table. Obviously, we know hydrogen is not a metal, but they're generally on the left-hand side. And then your non-metals are usually on the right-hand side. Okay. So we know aluminium is a metal, but all of these here, these are all non-metals. Okay. So if you want a quick kind of cheat sheet, your ionic bond is between things on the left-hand side and things on the right-hand side. but more specifically, it's a metal. And
My teacher wrote it out in also a specific way. So,
okay, you can read that out to me while I'm doing this.
well, it was I don't have, he did it on the board.
Yeah.
It was like he drew the symbol and then he drew all the electrons around it.
Yeah, don't worry,
And
we'll
then-
get there. Okay.
Right.
So that's why I've got the periodic table up. But you kind of need to start with the basics in that you need a go-to, right? So if you get confused and stressed in an exam and you're wondering if it's a covalent or ionic, at least this will kind of help you to know that, okay, a covalent is two nonmetals and an ionic is a metal and a non-metal. Now I'm going to get to our what you're talking about with what your teacher is saying where you have your symbols. Okay. Now, before I go on, I just want to talk about this periodic table quickly. And what we have on the right-hand side, or the left-hand side, should I say, with your non-metals. You can see me drawing here, so I'm actually going to erase what I've had here. Can you see that I'm drawing that hydrogen there? There's the hydrogen
Yeah.
there. Okay, now how
Yeah.
many electrons does a hydrogen have?
One.
Okay. So this would be what your teacher would have been drawing when he would take a symbol, and he would do a hydrogen there. But instead of drawing it in its orbital like this, he would maybe do it like this, right? With a little star.
Well, yes.
To represent an electron. So this is a simplified way of drawing the hydrogen. And notice that when we look at our periodic table, if I was to draw something up here, this is the helium up here. Okay. So this first row has 1, 2, 1, 2, right? You see the hydrogen, helium. That is because our first orbital, so if you can think of electrons going around the nucleus, they are like planets, they're like moons on a planet, and your first orbital can have 2 electrons. Okay. And so helium, this is why helium does not react, because it has 2 electrons. And remember, when electrons bond together as pairs, then they don't need to react further, because that's how they bond. So if we look at our hydrogen, why is hydrogen so reactive? Because it's got this 1 electron, right? And so it has space for another. And so it's going to bond with something. I've drawn lithium down here. So if we look at lithium in the second row, 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay. So and if we look at 8 electrons, that means that the second orbital, so your second energy level, can have 8 electrons. So if we look at lithium, lithium has 1, 2, and 3 electrons. So it's got this full inner orbital. So this is much like helium, this lithium in the first row. So I'm going to do it in yellow to show what part of lithium would be like helium would be this, right? Can you see that it's got the 2 electrons in there? So it's much like helium in the center, but then on the outside, it's got this 1 more electron, which is what we call a valence electron. And that's an electron that can bond with other electrons.
Wait, so it has an extra?
Yeah, well, it has another electron. See, as we count hydrogen, helium, lithium, beryllium, we add an electron each time. Okay.
Yes.
And so these electrons can bond. And we'll look at an Aufbau diagram later, but let's just deal with one thing at a time. What I'm drawing here is hydrogen. And now hydrogen, H2, can bond.
Okay.
I don't know why I've drawn 2 electrons here, but the hydrogen bonds with hydrogen to form H2, hydrogen gas. So that should really look like this. Hydrogen, hydrogen, with a bond like that. And these would be the 2 electrons here. Forming this bond.
Okay.
So if you take hydrogen, so I could draw it like this. Your teacher might draw it like that. And then maybe like this. And so the star and the dot, they're both electrons, but when you draw them together, you can differentiate and say, okay, so the star was from the one electron and the dot was from the other. And so that could then finally be represented by H2. So that would be the H2 molecule.
Yes.
Okay, now what type of bond is H2?
H2 would be a covalent bond.
Yes. Good, because it's 2 nonmetals.
Yes.
Okay, now the next thing I want to talk about is, you don't have to know this as much now, but electronegativity, I've written the values here. So if I was to write the electronegativities of some of these in orange, your hydrogen is 2.1, and your lithium is 1, and your sodium is 0.9. Notice that it gets lower and lower as we go down. Okay, the periodic table. And if I was to write, okay, helium, neon, and argon, they don't have values. Let me just tell you that electronegativity is how much your atom wants to hold on to its electrons. And helium, neon, and argon, when they were trying to figure out the electronegativities, they were off the charts. Because helium, neon, and argon, they just do not want to react. So they really do hold on to their electronegativity. So helium is not 0. It's just very, very high. And so when you look at your electronegativity, it'll just have like a dot or something. It'll have it blank. What I'm concerned more with is fluorine, which is 4.
Because my teacher said we need to be able to know how to also along with the covalent bonding, what it is, and like a way to show her that you understand it. And with the Aufbau diagram, he said we need to know how to do it for the first 20 elements.
Yeah, don't worry about that. We'll get to that. Okay.
Okay.
You first have to understand your first question, which is what is an ionic and a covalent bond. I want to just talk about the electronegativities because this is going to help you remember. Now, going across the table, your electronegativity gets bigger. Do you notice that? 2.1, 3.5, this nitrogen was 3. Okay.
Yes.
Now, electronegativity is how much your atom wants to hold on to its electrons. So as we add electrons as we go across, right? I'm adding electrons each time, right? Each time I go onto a new element, right? I add an electron.
Yes.
So what that does is as you add more electrons, they pull in closer to the nucleus. Because you've got, remember, what is the nucleus, positive or negative?
Positive.
right? So if you put more electrons on, you add more electrons.
More, yes.
And so they pull in closer. As you go down the table, what happens? Remember when we went from helium to lithium? We added an electron orbital. If I go to sodium, I add more. Now, this idea of adding more electrons each time is going to help you with your Aufbau diagram. So don't worry, we'll get there. This sodium on the outside, if I add another, the sodium would have the full thing like lithium, sorry, like neon, which is the first noble gas before sodium. And then sodium would have another one. So notice that as I go down the table, I add another orbital. Okay, so potassium would be another one. Do you understand that? I'm adding another orbital going down, right?
Yes.
Okay, so this is also, this will all tie together with the Aufbau diagram. Now, this means that if I think of a magnet, when you push two magnets together, what happens? Do you feel it's stronger, right?
Well, if it's they're the same charge, then they push each other away.
Okay, but let's think of opposite magnets, because our nucleus is positive and our electrons are negative. So if you push closer together,
they want to come together, so
yes,
they pull each other together.
Right, now if I pull it apart, is it stronger or weaker?
Weaker.
Yes, and that's what happens here. So that's why our electronegativity decreases as you go down, because this last electron here on the very outside is further away from the nucleus. Okay.
Okay.
So it's important to understand electronegativities, because that will help you now with bonding. So we've talked about the covalent bond being between two nonmetals.
Right.
So yes, right? Got it?
Yeah.
You got that?
Yes.
Covalent bond, two nonmetals.
And then ionic bond, a metal and a non-metal.
Yes. Now, there is another thing that when you get to varsity, they'll talk about, and that is that a covalent bond, when you look at the electronegativities between the two atoms,
right.
So the difference in electronegativities, they are between 0 and 0.4, which is very small. Now, when I say the change in electronegativities, that means the difference in electronegativity. Now, think of hydrogen and hydrogen. What is the electronegativity of hydrogen? 2.1, right?
Yes.
And the other hydrogen is also 2.1. So the difference in electronegativity is 0.
Yes.
So that's covalent. And this really helps us when we look at why.
Wait,
okay.
so the difference between an electronegativity for covalent bonding will always be 0.
Not always 0, sometimes less than 0, because we know CH4 is a covalent bond, right?
Right.
And what's C? I wrote 2.5, right?
C is a non-metal.
Yes, but what is its electronegativity? I did write it down here earlier, is 2.5.
2.5, right.
And hydrogen is 2.1. So if we look at C and H, okay,
Yes.
that we drew earlier, CH4, if I just look at the C to the H bond, carbon is 2.5 and hydrogen is 2.1. So what's the difference?
Wait.
2.5, 0.4. 2.5 minus 2.1 is 0.4.
Wait. Oh, okay. Yeah. Yes, I understand. Yes.
Okay, now at the moment you don't get given the electronegativities, I believe. So it's just easy for you to remember that it's a two nonmetals. But what you can also look at, if you're not sure, is if the things are really close together, if the elements are really close together, it's probably a covalent bond.
Right.
Because the difference in the electronegativities between them is not very high. Okay, so there's two things we can kind of remember about a covalent bond. One is that it's just two nonmetals. And so if it's H2 or O2 or things, because they have the same electronegativity, they automatically have the same, they automatically are covalent bonding. Two metals, but metals have the same electronegativity. But don't confuse metallic bonding with covalent bonding. Okay, so just because sodium has the same bond as sodium, this is not a covalent bond. This is a metallic bond.
Okay.
Yes. So if you look at the sides of the table, it'll help you to see, you know, that on the left-hand side is mostly metals. And on the right-hand side, especially this top right-hand side, this is all the non-metals.
Okay.
Okay, so we've done covalent bonding. Let's do ionic. So ionic, we said, was between a metal and a non-metal.
Yes.
Okay, so this is where we can go through and show you what your teacher was talking about, which was I'm going to clear all the drawings here. And I'm going to just pause this. And let's annotate. Okay, now you can see in the background, I've been talking about sodium here. So,
yes.
so sodium, I took off the values of the nonmetals of the electronegativities, but sodium we remember is 0.9.
Yes.
Hydrogen was 2.1 and lithium was 1. So if we take sodium, because the sort of the famous ionic bond that people love to teach is sea salt, or salt actually. But in science, table salt is the salt that's NaCl.
Yes.
Now this is table salt. In science, salt can be a lot of things. MgCl 2 is also a salt. Okay, but we think of sodium and chlorine as table salt, so we know that in our thing. Now, if I look at sodium, it's in group 1. Okay. So how many valence electrons do these in group 1 have?
1.
Excellent.
1 plus.
Yes, good. So there's our 1. So I'm going to draw that valence electron on the sodium. So there's
So the valence electron, does it mean so it already has a number of electrons?
correct.
So
in
if
this
it
case,
has the
10.
valence electron, is that an extra added one?
Well, it's on the outside. It's not added because it's.
But is it like, would it be like, just say an element with 20 electrons and a valence, 1 valence electron? Would that be 21 electrons in total?
No. Sodium has 11 electrons. I
Right.
count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It doesn't have an extra electron. You're thinking of an ion. Don't worry about that. So this sodium has 11 electrons, but the fact is that 11 is an odd number. This 11th electron is on the outside. Okay, so when we talk about you say the number of electrons, we've got 10 inside this yellow area here. Okay, and we've got that one on the outside. Okay.
So that one is the valence electron.
Yes, and that's the one that can bond with
Oh.
other electrons.
Okay.
Now look at chlorine. So chlorine
Yes.
is a little bit past sodium. Now
So
we know
it's
that,
17 electrons.
yes, excellent. Now we know that
But
chlorine
it's
has a electronegativity of 3.5 that we're going to talk about just now. Right,
so
so
would that be
chlorine,
-2?
no. How many? No, chlorine has how many valence electrons? 1, 2, 3, 4, 5, 6, 7.
Is that not negative?
No, don't worry. I'll talk about, no, I'm going to talk about we haven't even got there yet. -1, -2, what all that means.
Okay.
No, just think of chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So I can draw them like this, okay? Do you see why it has 7? What group is it in?
Wait, chlorine is in group 7.
Right.
Wait, no.
Yes, 7 valence
Yeah.
electrons.
Yeah, 7.
Yeah, count the groups. 1, 2, skip the transition metals, 3, 4, 5, 6, 7. When you get to university, these get called they'll add them, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They'll call this 13, but don't worry about that. For now, grade 9, call it number 3, group 3. So these would have 3 valence electrons. This one has 7. Okay, so remember when you said hydrogen has 1 valence electron, so does sodium? Easy because it's in group 1. So if I look at this, all atoms aspire to be noble. Okay, and noble is this?
The unreactive.
Yes. So look at where sodium is on the periodic table. Do you think it's easier for it to go and get 7 electrons or to lose 1 and become like neon?
To lose 1.
Yes. So it donates, right?
Or then that's what the valence electron is.
Yes. So this valence electron gets donated. Now, chlorine has 7 electrons. Do you think it's better for chlorine to donate 7 or to just accept 1 and become like argon?
Accept 1.
That's right. So this is a very obvious exchange, right? So the sodium gives up the 1 electron, donates, and chlorine is accepting it. And so this would be an ionic bond. Okay.
Okay.
Now, mostly easiest way to remember, it's a metal and a non-metal. Chlorine is a non-metal. We know chlorine gas. But the other thing I spoke to you about was electronegativities. Well, look at sodium. It's all the way on the left-hand side and it's 0.9. Okay, remember these traditionally have fairly low electronegativities. What is chlorine's? 3.5, all the way on the right-hand side. What is the difference between these two?
Between chlorine and
Sodium.
the difference in valence electrons.
No, in
the difference is in the sum.
Yeah, 3.5 minus 0.9, right?
2.6.
Okay, now anything. Okay, so there's different textbooks. I don't want to confuse you. So I'm just going to say that there's not 100% consensus here in the textbooks, but anything about 1.8 or bigger difference is ion.
The sum.
Yes, the difference between the electronegativities. We're going to break up soon. So I'm going to, once we do, I'll stop this and start a new video when we join again. Okay, so, but basically small electronegativity difference, covalent. Big difference, ionic. Two nonmetals, covalent,
Covalent.
metal, nonmetal, ionic.
Ionic, yeah.
Right, and we can see why, because you have them on opposite sides of the periodic table. So they would then donate electrons. So the ones on the left like to donate